Hi everyone, my name is Callista and I'm a recent graduate from the University of Chicago. Today I will be presenting my project with Dr. Anjali Adukia and Dr. Doris Saz in the Me Lab on measuring race and gender in children's books. One significant early influence in a child's life are the books they read at home or in school. Using notable children's textbooks and storybooks from a span of almost 30 years, like the one shown here, the Me team aims to use machine-guided techniques to quantify the race and gender inequalities that exist in numerous books throughout time. After doing so, we can then measure the impact these race and gender messages have on children by connecting our results to student-level administrative data. This summer, I worked on the image team where we used machine learning to classify race, gender, and age in characters and photos in these books. Measuring race and gender in images is not a straightforward task at all, and I'll now get into the details of the methods we used to do this, along with the challenges we faced along the way. The workflow for classifying the race, gender, or age of any photo or cartoon is shown here. The first step is actually detecting the faces that are depicted in the books by using AutoML or Google Vision API models, and then removing the background so that we get rid of any unnecessary information and just keep the face. The second step, if you're predicting age or gender, is to run the AutoML models on the cropped face to obtain age and gender classifications. Now, if you're trying to predict race, it's a bit trickier. We must first segment the face so that only the skin in the image is showing. And once we have that image, we're able to run the skin prediction algorithms using k-means clustering on the segmented face to obtain the race classification. Again, this seems pretty straightforward, but it's not actually always that easy, and so I will now touch on some of the hurdles we face when doing this kind of work. This summer I worked specifically on the skin color classification task, and so I can talk about the challenges I've encountered there. Even though we have a fair amount of data, the fact that the face detection models were trained on non-cartoon data means that it might not work perfectly on cartoons. For example, I found about 60 to 70% of the data for cartoons specifically are not able to be used because the skin segmentation algorithms incorrectly segment the skin from the image, as seen in the top left picture. Eventually, we'll want to either improve our models to better handle cartoon data or apply the old models to more data to get more representative results. Another issue are shadows. So shadows in an image greatly influence our classifications for skin color, as shown in the top right image. It's hard to assign this picture to one bin, and from a human perspective, the darker skin color in that image seems like it is probably a shadow, but again, it's hard for computers to recognize that. Also, our initial skin color bins were determined somewhat arbitrarily and are depicted in the bottom picture. We'll have to do some literature research to see what the optimal number of skin tones is and make this process as objective as possible. Even despite all of these challenges, we were able to get some preliminary skin classification results for cartoons. The plot on the left depicts the percent of faces labeled in each specific skin color bin, and the plot on the right shows the average skin color each year over time. By looking at both of these plots, you can see that the diversity in skin tone increases throughout time for this specific corpus. But in addition to how often specific groups of people are being portrayed, we care about the way they are being portrayed. For example, what kinds of careers are people with different skin tones associated with? What kinds of clothes are they wearing, etc. In order to answer these questions, we will need to combine all of the image and text team results. There are obviously a lot of challenges we are facing with our current tasks, but some additional work we plan on doing in the future is to incorporate full body detection in order to determine what clothes and accessories are associated with different races and genders. Additionally, we're going to be looking at how objects in the background or objects being held by that character are associated with that character. Lastly, we are excited to look into the physical and emotional interactions between characters and their environment. all of which might prove useful in finding hidden messages in these books. Thank you so much to the Me team for allowing me to join this amazing group and for being excellent mentors. And of course, thank you to the CDAC Summer Lab program for a great and productive summer. Thank you for watching.